Example 2. For the retaining wall shown in figure below, determine the lateral earth force at rest per unit length of the wall and then compute the location of the resultant force. Here we have a retaining wall and the backfill is sand soil, gamma equal to 16 kN per meter cubic, and saturated unit weight equal to 19 kN per meter cubic, angle of internal friction equal to 30 degree, cohesion equal to 0. Here the water table at depth equal to 3 meter. We want to compute the lateral earth pressure at rest, which means that the retaining wall is restrained and there is no movement to left or right. First, compute at rest lateral earth pressure coefficient by using Jackie's equation. K naught equal to 1 minus sine phi, 1 minus sine 30 equal to 0.5. Here construct the following table. At depth equal to 0, sigma vertical will be 0, since sigma vertical equal to gamma dash multiplied by z. In the second point at 3 meter depth, here at 3 meter depth, K naught equal to 0.5, since the soil is the same at this point. Sigma vertical equal to 3 meter multiplied by gamma equal to 16 times 16 equal to 48. Sigma horizontal, the horizontal stress will be K naught times sigma vertical. K naught 0.5 times 48 equal to 24. Here at this point the stress will be 24. At 7 meter at the bottom of the retaining wall, here at this point the vertical stress or overburden pressure equal to 3 meter multiplied by 16 plus 4 meter multiplied by gamma dash 19 minus 9.81, just one this one, equal to 84.76 kN per meter squared. The horizontal stress will be K naught multiplied by sigma V, 0.5 multiplied by 84 equal to 42.38. Here at this point the stress will be 42.38. We can draw the stress distribution along the depth as in this figure. The hydrostatic pressure can be also calculated. At depth 0 will be 0, at depth 3 meter also 0, since the water table at depth 3 meter. Here at the bottom will be 4 multiplied by 9.81 equal to 39.24 kN per meter cubic, and can be linearly distributed with depth. To compute the resultant, we have to divide this area into a triangular area here, and rectangle and triangle, and then compute the area of everyone. The area 1 is the area of the A1 is the area of the triangle, A2 is the area of the rectangle, A3 is the area of the triangle here, and A4 is the area of this triangle. P, the resultant force. The resultant force will be 1 over 2, the area of triangle, 1 over 2 multiplied by the base 24 times the height 3 plus 4 meter multiplied by the base 24 plus 1 over 2 the height equal to 4, and the base here will be 42.38 minus 24 plus 1 over 2, 4 meter multiplied by 39.24 equal to 247 kilonewton per meter. The resultant of the lateral earth pressure will be 247.24 here, but we don't know the location of this resultant. Assume that the location with respect to the bottom of the retaining wall will be Z dash. Assume Z dash is the location with respect to bottom of the retaining wall. Since the moment of the resultant about point, for example, B here at the bottom, equal to the moment of all the components, all the forces about the same point, as we know from the mechanics, from the statics, as we learned in the first course in civil engineering. To compute the location, therefore, Z dash will be the moment of all the forces about this point divided by the resultant. A1 is computed previously equal to 36 multiplied by the R. 36, the arm of the first spur is 5 meter. It's 5 meter, since this is 4 meter, and here 1 over 3 from the 3, 1 over 3 multiplied by 3 is 1 meter, plus A2 69 multiplied by here multiplied by 2 meter, since the center of the rectangular area is 2 meter here from the bottom, plus A3 is 1 over 3 multiplied by 4, 1 over 3 multiplied by 4, third the height of the triangle, plus A4 here also the same value of R, 4 over 3 divided by P naught. Z dash will be equal to 2.086 meter. Therefore, the resultance acts at a distance equal to 2.086 meter from the bottom. We can calculate the distance and the center of the lateral earth pressure with respect to the top, to any point at the top or at the bottom. Here we compute the center of the lateral earth pressure with respect to bottom of the rectangle of the retaining wall.